Hello students, part 1 of my lecture on chapter 2, Labour Supply. Let's start with some definitions. The US Bureau of Labor Statistics defines something called the working age population. And the working age population consists of everyone who is 16 years or older, not in the military, and not institutionalized. Now, what's meant by being institutionalized? Well, that's being in jail or a mental hospital or something of that nature. So we're looking at people who are not in jail, etc., not in the military, 16 years or older. That's the working age population. It's also called the civilian non-institutional population. And this population is broken up into two subgroups. You have those who are out of the labor force and those who are in the labor force, right? And the labor force itself is broken up into the employed and the unemployed. And let's start by defining someone who is employed. How does the US government recognize an employed person? Well, the employed person has to be working at least 1 hour a week for pay, or at least 15 hours a week without pay in a family business. Well, that's the most common definition of someone who is employed, right? So who is unemployed then? An unemployed person is someone, of course, who is non-employed by the former definition. So this would be somebody who is not working even 1 hour a week for pay, or not even 15 hours a week without pay in a family business, right? But this non-employed person has to be actively looking for work to be considered unemployed. So the unemployed individual is a non-employed individual actively looking for work, right? And these two groups then make up the labor force, right? So who is out of the labor force? Who is out of the labor force? Well, that would be someone who is non-employed and not looking for work, correct? Because if you're non-employed and looking for work, you're unemployed. You're out of the labor force if you're non-employed and not looking for work. So a good example of this, of course, would be retirees, right? Or full-time homemakers or full-time students unable to work because of their course loads, etc., right? So that's out of the labor force, right? And these groups together, as I said, make up the civilian non-institutional population or the working age population, right? So this is being talked about in some more detail here on this slide, which I'm going to skip. I've spoken about this. And now let's define the unemployment rate, the labor force participation rate, and the employment rate. And to do this, let's go back to our tree diagram. So what is the unemployment rate? The unemployment rate is essentially the number of the unemployed. So we're talking about these individuals here, the number in this box, expressed as a percentage of those in this box, right? So this is the unemployment rate, the percentage unemployment rate, UR, for the unemployment rate. That will be the number unemployed divided by the number in the labor force times 100. That's the unemployment rate. Right, what's the labor force participation rate? The labor force participation rate would be those in the labor force expressed as a fraction of the working age population. So the labor force participation rate, again a percentage figure, labor force participation rate. That's defined as the number of individuals in the labor force expressed as a percentage of the working age population. Right? And there's a third fairly important definition that is used quite often by the government. That's called the employment rate. And the employment rate would be the number employed expressed as a percentage of not the labor force, but the working age population. So we're really talking about drawing a line, let's say from here, like this, all the way to this box, correct? So that would be the employment rate, again a percentage figure, That's the number employed divided by, I'm sorry, just correct that, so that would be the number employed, sorry, not the percent sign. Number employed divided by the number in the working age population times 100. And this is equal to the percentage employment rate. Right? Let me just tidy that up a little. Just tidy that up a little bit. There. So we got the basic definition here. In this chapter we'll talk quite a lot about the labour force participation rate. Okay. So some facts about trends in US labour force participation rates. First, the male labour force participation rate has seen a long-term decline from 80% in 1900 to 71% in 2010. How would you define the male? How would you define the male labour force participation rate? We know what the labour force participation rate is, right? It's the number of individuals in the labour force expressed as a percentage of those in the working age population. So what is the male labour force participation rate? Well, that would be the number of males in the labour force, and we divide that by the number of males in the working age population, and we multiply this fraction by 100 to convert into a percentage. So that's the male labour force participation rate. The female labour force participation rate would be the number of females in the labour force expressed as a fraction of females in the working age population. Okay. So as I said, the male labour force participation rate is seeing a long-term decline. The female labour force participation rate, on the other hand, has seen a long-term increase, a pretty dramatic long-term increase from 21% in 1900 to 60% in 2010. Right? Another thing to observe is that the average number of hours worked per week has again seen a long-term decline from 40 in the year 1900 to 34 in the year 2010. Right? Some more facts. The labour force participation rate is highest for all demographic groups during the age 25 to 55. So whether it's men or women, the labour force participation rate is highest for this age group, 25 to 55. It's smaller for those younger than 25, and it's smaller or lower as well for those above 55. Another fact that's been observed in the US is that the labour force participation rate increases with education. So the more educated people are more likely to be participants in the labour force than those with less education. Right. Thirdly, the labour force participation rate for males over the age of 65, so we're talking about older males here, well, that has seen a very sharp decline between the years 1900 and 2010. In the year 1900, 63% of this demographic participated in the labour force, and that figure has fallen to under 22% by 2010. In other words, in the old days, men sort of postponed retirement. Many people just never retired. They just went on working, even when they were old. But these days, it seems that more and more males in particular leave the labour force upon turning 65. Good reason for this, of course, is the existence now of social security, which wasn't present in the year 1900. All right, now the microeconomics of labour supply. So here you're going to go back to your theory of the consumer, which you would have learnt in Econ 2302, Principles of Microeconomics, in difference curves budget lines. So we will use that framework in difference curves budget lines to work out the optimal number of hours worked for an individual. Right? So we can work out the individual's labor supply using consumer theory. Right? So let's start with preferences. Right? And you know that in Econ 2302, you probably saw diagrams like this. You had a good X measured along the X-axis, and you had a good Y measured along the Y-axis, and preferences were represented by these indifference curves. So what's true along an indifference curve? Along an indifference curve, all of the XY combinations yield the same level of satisfaction or utility, correct? In our case here, we have two goods also. The two goods happen to be hours of leisure measured along the horizontal x-axis. Right? Leisure is something that's enjoyable, it delivers utility. Right? So that's our first good. And along the vertical axis, we will measure consumption, all the other things that we consume. Right? And we are going to assume for simplicity that the price of this composite consumption good is $1. Right? So $1 of earned income will enable you to buy 1 unit of this consumer good. Right? So here we have these two different individuals. One of them has rather steep indifference curves. This person has steep indifference curves, and the other person seems to have rather flat indifference curves. What's the difference between these two individuals? Who values leisure more, do you think? Right? Well, the answer to that is the person with the steep indifference curve, you see? Because if you were to take away from this guy here, along his indifference curve labeled U1, the blue indifference curve, let's say he's here currently, and you want to take away an hour of leisure from him. By how much consumption would you have to compensate him in order for him not to be hurt, in order for his level of satisfaction to remain unchanged? So that would be this vertical distance here. So you see that a considerable amount of consumption would have to be given him if an hour of leisure were taken away from him. Correct? Now let's contrast this with this individual here, the one with the flat indifference curve. If you took away the same hour of leisure from him, you would need to compensate him with much less consumption in order for his utility to remain unchanged at level U1. Right? So who values leisure more? Clearly this person here on the left, the one with the steeper indifference curve. Right? As you know, the higher the indifference curves, the higher the level of utility. So utility level U1 is bigger than utility level U0. This you would have learnt in Principles of Microeconomics. Next we need the budget constraint. Right? Our preferences we just spoke about, and now we need the budget constraint. Right? And what does budget constraint define? It defines the worker's opportunity set. Right? All the combinations of leisure and consumption that a worker can afford. That's what the budget constraint or the budget line describes. So what is our equation for the budget constraint? First, let's define a few terms. We have W here, which denotes the hourly wage. This is a dollar figure, right? The hourly wage. H denotes hours of work. Capital V denotes non-labor income. So this is income from other sources, not from one's labor. For example, financial investments or rental property. So let's say you own a block of apartments, right? And you receive these rents from your tenants. Well, that would be non-labor income. Right? So consumption has to be equal to W times H. Now what would W times H be? That would be labor income. Right, so let's say that your hourly wage is $8 an hour, right? And you work 10 hours, if H is 10 and W is 8. 8 times 10 is $80. That would be your weekly labor income. To this we add non-labor income V. And so WH plus V would be total income. And with this income, the worker can buy the composite consumer good. right? So C has to be equal to WH plus V, right? And let's also define capital T, and capital T, which is the second bullet item here, is the total number of hours available to the worker. Now, would this be 24 hours in a day? Well, not quite, because we have to sleep, etc. So, in actual fact, the number of hours available to us is less than 24. Something like perhaps 12 or 14 hours, let us say. Right? So this is capital T, that's the total number of hours available to the individual per, let's say, day. Right? And so capital T must be equal to capital L. Capital L stands for hours of leisure, hours of free time, plus H, which is hours of work. So hours of leisure plus hours of work equals capital T, the total amount of time available to us. So if we take this statement here and we just rearrange it, we can write H as equal to T minus L, correct? So we have H is equal to T minus L, and let's take this H equals T minus L and let's substitute it into the budget constraint. Let's replace the H here by T minus L, and if we do that, our budget constraint begins to look like C is equal to W times T minus L. This of course is H, right, plus V, right? And if we do a little bit of rearranging here, we would end up with W times T plus V is equal to C plus WL, right? Now this is a useful way of looking at it, because the item on the left hand side, WT plus V, you can think of this as the consumer's full income I, right? What is full income? This is the income that he would have earned if he had worked all the time, if he had spent his entire T hours working, right? So WT plus V would be that's his potential income, his full income. And he uses this full income in two ways. He uses it to buy consumer goods, C, and he also uses it to buy leisure, L, right? And what's the price of the consumer good? You see there is a 1 here, and I'd assumed, remember, that the price of this composite consumer good is $1 per unit, right? And what's this W here? This W here is the price of leisure. Does leisure have a price? Well, it does, in an opportunity cost sense. Because every hour of leisure is one lost hour of work, which would have earned you W dollars. Correct? So WT plus V, full income, is equal to C plus WL. So you can think of the individual as using his full income to purchase the two goods that give him satisfaction. What are they? The consumer good or the consumption good plus leisure. What's the price of the consumption good? $1 by assumption. What's the price of leisure? The hourly rate. Right? And we can graph the budget constraint as follows. So what we have here again, it's C is equal to WH plus V, correct? This is labor income. This is non-labor income. And then replacing H by T minus L, we arrive at this equation here. C is equal to WT plus V minus WL, right? So let me write this here. C is equal to WT plus V, in brackets, minus WL. Now, isn't this of the form y is equal to b plus mx? And that, of course, is the equation for a straight line, isn't it? And what's the b there in the equation for a straight line? Well, that would be the y-intercept, and that's what this y-intercept is here. Correct? So this is the y-intercept of the budget line. And m, what does m indicate? M is the slope. And what is our m in this case? Minus w, as you can see. Right? So that's the slope here, this slope here, minus W. Now why do we have minus sign? Because any lines that are sloped this way, meaning starting out in the south east and ending up in the northwest, well, these are negatively sloped lines. So their slopes are mathematically negative, because we're always going to refer to the slope in terms of its absolute value. So we're going to say the slope is W. Really, it's minus W. Okay? So what does this point E represent? What does point E represent? Point E, of course, would be the point of consumption if this individual did not work, if this individual consumed the entire T hours as leisure, right? If the individual did not work at all, that would be the amount of leisure consumed. And how much consumption would this person be able to afford? Well, whatever that his non-labor income can buy. His non-labor income is V, correct? So this point here is basically combination T comma V. The T is leisure and V is the amount of the consumption good. Right? So point E then is the point of no work. Right? And thereafter, if the person gave up some leisure, let's say decided to give up 1 unit of leisure and consumed only T minus 1 hours of leisure, this means that this person is working 1 hour. So this is the hour of work. Right? And this would enable the individual to earn W dollars. And so what would consumption become? What would consumption become? Consumption would become, go all the way to the consumption axis, poorly drawn, I apologize, and that would be how much? It would be V plus W, isn't it? Because you have, the person has the old non-labor income, but to this can be added the wages from that 1 hour of work. And V plus W together then enable the individual to buy a consumption good. Correct? So this is the budget line. You can see here that there is this kink at point E. Keep that in mind. Right? Now let's come to the hours of work decision. Right? Now we know from Econ 2302, we know from Econ 2302 that given a certain budget line, I'm going to draw one here. I apologize for my slightly crooked drawing. The technology I'm using is a little ancient. But anyway, so you have good X here and good Y here. And what you'd have learnt in Econ 2302 is that utility is maximized where on this budget line? At the point where an indifference curve is tangent to this budget line. Is that correct? That's the highest attainable utility. Right, so let's call this U star. Right? So given that budget constraint, U star is the highest amount of satisfaction that is attainable, and this level of satisfaction would be achieved if the individual bought this particular combination of good X and Y. What combination is that? I'm going to label it point A. So combination A on its budget constraint maximizes the consumer's utility. Right? We're going to use a very similar argument here to figure out the optimal amount of leisure and the consumption good for the worker. And of course, once we know his optimal leisure, we can work out his optimal hours worked, because hours worked, remember, is simply T minus hours of leisure. Right? So once we have optimal leisure, all we go is T minus that optimal leisure. And that will give us optimal hours worked. Right? Now what's true about point A? Well, at point A, as you may recall from your principles of microeconomics, what's true? The slope of the budget line is equal to the slope of the indifference curve. Now, what's the slope of the indifference curve? The slope of the indifference curve has a certain name. I don't know if you remember it, but it's called the marginal rate of substitution. In our case, it's the marginal rate of substitution of leisure. This is the good you're measuring along the x-axis. For consumption, the good being measured along the y-axis. So it's the marginal rate of substitution of x for y, and leisure for consumption. That's the slope of the indifference curve. And so at point A, the slope of the indifference curve must equal the slope of the budget line. And what is the slope of our budget line? What's the slope of our budget line in absolute terms, ignoring the minus sign? It is, of course, as we've seen here, it's the hourly wage rate. Correct? So essentially then the worker is going to maximize his satisfaction, or her satisfaction, where the marginal rate of substitution of leisure for consumption equals the wage rate. In other words, where the slope of the indifference curve equals the slope of the budget line. Right? And that has been shown right here. So if you look at these numbers here, you first can see that the total number of hours available to this individual are 110 hours. So clearly this will not be per day. Perhaps this is a monthly figure. Right? Right, so 110 hours is the number of hours available to this individual for work. Let's say a month will be too long. Yeah, maybe this is a week. Okay. Maybe this is a week. So this is your capital T. Right? Can you look at this diagram and tell me what V is, the non-labor income? And you can see here that non-labor income is $100. In other words, if the person did not work at all, consumed the entire 110 hours as leisure, this person would be able to buy $100 worth of the consumption good, financing this purchase using non-labor income. Right? And you can see here that the best point for the worker is point P. Right? This is where an indifference curve is tangent to the budget line. So this particular worker does best by consuming how much leisure? 70 hours of leisure, right? And this will enable the worker to have a total income of $500, of which $100 is non-labor income. So labor income then will be the difference, 500 minus 100. So that 400 would be labor income, right? And this would enable the individual to consume at point P. So what is the utility maximizing hours of work? Well, the hours of work would be, of course, the difference between 110 and 70. So this gap here indicates hours of work, hours of work, right? What would happen if this individual experienced a rise in non-labor income? Right? So let's say non-labor income went up from $100 to $200. So this would mean that the budget line now, instead of being here and then having and you see this kink at point E0 and there's blue line, instead of that it now goes up, the kink moves up to E1. What do I mean by the kink? The kink is the place where you have the sharp turn in the budget line. It goes from being negatively sloped to vertical, right? And what we have seen here is that the new negatively sloped portion of the budget line, the new portion, is exactly parallel to the old negatively sloped portion, right? And this gives us what's called a pure income effect. So if leisure were a normal good, right, if leisure is a so-called normal good, and again this is something that we call from principles of macro and micro. What's a normal good? A normal good is one that the consumer buys more of, the higher his or her income. Right? So if leisure were a normal good, you would see this individual buying more leisure, consuming more leisure, going from 70 to say 80 hours of leisure, and this would be a move in this northeasterly direction, as you can see, from point P0, the old optimum, to point P1, the new optimum on the new budget line. Right? So if leisure were a normal good, an income effect would lead to more leisure being consumed. And what does that do to hours worked? Well, hours worked clearly falls. It used to be 110 minus 70, which is 40 hours, it falls to 30 hours of work. Right? So one of the predictions of this theory is that if you gave someone non-labor income, this person would probably reduce his or her hours of work. Makes sense, right? Somebody wins the lottery, for instance, this person is bound to reduce his or her hours of work, generally. Right? Remember, this is non-labor income. Right? This is a rise in non-labor income. Now, what if leisure were an inferior good? Now, this is generally unlikely to be true. But, theoretically, let's say that leisure were an inferior good. In this case, if non-labor income went up, instead of moving in the northeasterly direction that I showed you in the last diagram, instead of going in that direction, now the movement is going to be in the northwesterly direction, because with this rise in income, leisure being an inferior good, the worker would buy less of it. That's the definition of an inferior good. That's like ramen noodles. Ramen noodles, right? If your income goes up, the chances are you buy less ramen noodles. Or fast food, or Big Macs. The higher your income, the lower the number of Big Macs you'd like to consume, unless of course you're Donald Trump, right? He likes his Big Macs. So chances are that, so if leisure were an inferior good, a hike in income would cause the individual to buy less leisure. So he'd go from buying 70 units of leisure, right? He'd go from buying 70 units of leisure to 60 units of leisure. So his hours of work go up from 110 minus 70, which is 40, to 50 hours of work. But this is an unlikely scenario, right? Because leisure is unlikely to be an inferior. Now let's talk about a rise in the wage. Not non-labor income, but the wage. So what would happen is this. Now what is the old wage? The old wage, of course, would be this slope here. This slope, let's call that W1. Correct? Now if the wage were to rise to that slope, let's call that W2. Right? So we have a higher wage, W2 is bigger than W1. You have the budget line essentially swiveling outwards, swiveling sort of rightwards, right? And what's the point of the swivel? The swiveling occurs at this point here, which is the point of no work, right? So this is the point where the swiveling occurs, and the budget line essentially swivels in that direction. Correct? So what is going to be the effect of this? Well, let's say that point A was the old optimum before the swivel occurred, right? And to work out the new optimum, well, we can think in terms of substitution and income effects. Again, this is something that you have learned in principles of microeconomics, Econ 2302. Right? So if you're rusty with these terms, you can just quickly do a Google search, substitution effect, income effect, and it's all out there, really. A quick refresher. How do you work out a substitution effect? To work out the substitution effect, it's traditional to do the following. You draw an imaginary budget line parallel to the new budget line, but tangent to the old indifference curve. So that brings us to a point of tangency at point B. So A to B then is the substitution effect. So what this is saying is that as the wage rate rises, remember the wage is the price of leisure. Leisure becomes more expensive. So with leisure becoming more expensive, you are likely to see a substitution out of leisure into the other good being consumption. Right? So that's the movement from A to B. B compared to A involves less leisure and more of the consumer good. So this is the pure substitution effect. So the idea, you can think of this analogy. You have an individual cooking a so-called happiness stew in a pot. One of the ingredients in the stew becomes more expensive. So what does the cook do? The cook decides to use more of the other ingredient and less of this more expensive one. Right? That's the substitution effect. And then we have the income effect, which takes us in a northeasterly direction like this. This is like the pure income effect I showed you shortly before, the effect of a rise in non-labor income. Well, that would be a pure income effect, right? So this is similar. You're going from this imaginary budget line to the actual new budget line. That takes us from point B to point C. And that causes the individual to purchase more of both goods, assuming both goods are normal goods. So assuming leisure is normal, more leisure is consumed. So the income effect takes this person to buying more leisure. The substitution effect causes him to buy less leisure. So what happens in the end depends upon the relative strengths of these two effects. You see, if the income effect dominates, then the individual will in net end up consuming more leisure, meaning his hours of work would reduce, despite the fact that his hourly wage has gone up. So his hourly wage has gone up and his hours worked is reduced, if his income effect dominates. But if his substitution effect dominates, then the hike in the wage is going to cause him to consume less leisure. In other words, it's going to cause him to work longer hours. Right? And this, of course, would lead to a standard positively sloped labour supply curve. Right. So what does a labour supply curve look like? Again, pardon my bad drawing here. You have the wage, you have hours of work. And the standard labour supply curve is positively sloped like this. So the higher the wage, the higher the quantity supplied of labour. Now this would be true, as I said, this would be true only if the substitution effect dominates the income effect. Correct? Now, let's move on here. Now, here let me mention that your textbook draws the income and substitution effects a bit differently. But the way I drew them in the previous slide is I had the substitution effect first, then the income effect, right? But your book chooses to show the income effect first and then the substitution effect. So this is the original, the lower of the two budget lines. And that's the original budget line. Okay. So I think I've lost my cursor. Let's come back. So this is the original budget line, and then the wage rises. You have that right with swivel, and that's the new budget line. Correct? So point P was the old optimal. The individual consumed 70 hours of leisure, right? And then what your book does is it takes the income effect first. So what it does is it draws an imaginary budget line that is parallel to the old one, but tangent to the new indifference curve. Right? So this budget line is parallel to this one. This is an imaginary line, of course. Right? And that movement from P to Q is, of course, in a north-easterly direction. Right? So that causes the worker to consume more leisure, assuming leisure is a normal good. Correct? That's P to Q, that's the income effect. Then you have the substitution effect, right? And that takes you from Q to point R. R is where this indifference curve is tangent to the actual new budget line. Right? So you can see here that P to Q involving an increase in leisure is the income effect, and Q to R, which involves a decrease in leisure, is the substitution effect. So your book has shown this a bit differently. It's shown the income effect first and then the substitution effect. My diagram in the previous slide has shown you the substitution effect first and then the income effect. I believe that is standard in most texts, but substitution effect is shown first. But it doesn't matter, you can make the argument either way, right? Point is that in this diagram, which effect seems to dominate, you think? Well, the income effect takes this person from 70 hours of leisure to 85 hours of leisure. It's a 15-hour increase of leisure, right? And that's the income effect. And the substitution effect takes this person from 85 to 75 hours of leisure, which is a 10-hour decrease. So in this story, clearly you can see that the income effect, which is that, dominates the substitution effect, which is this. So the income effect dominates, and the worker ends up working fewer hours. The worker used to work 40 hours, but now works 25 hours, which is 110 minus 85. This despite the higher hourly rate. Right? So So in this case, what kind of a labor supply curve do we have? In this case, the wage there and the hours of work here, we have a negatively sloped labor supply curve. A labor supply curve that looks rather like a demand curve. Right? The wage rate has gone up and the worker is working fewer hours. Right? So more leisure at a higher wage. Does this happen? Can this happen? It can happen. It has been observed to be happening at very high wage levels, however. Right? So let's consider a brain surgeon. Right? And let's say his hourly wages are, I don't know, he's going to cook up an astronomical figure, $5,000 an hour. Right? If his hourly wage were to go up from $5,000 an hour to $6,000 an hour, this brain surgeon might actually decide to enjoy more leisure, go golfing more. Right? Because his income effect may dominate his substitution effect. But generally at lower wage levels, the kind of world that 99% of us live in, except the top 1%, but most of us, I think, would react by increasing our hours worked following a hike in our wage. In other words, for most of us, the substitution effect will dominate, and that's shown in this diagram here. So this is where the substitution effect dominates. The income effect is due to Q. That's the pure income effect, northeasterly direction. And that causes hours of leisure to go from 70 to 80. That's a 10-hour increase. But then you have this substitution effect from Q to R, which takes you from 80 to 65 hours of leisure. So in this case, substitution effect dominates, and the individual ends up working an extra 5 hours. The individual used to work 110 minus 70 hours, it's 40 hours. Now works an extra 5 hours, 45. Right? So this would give you a positively sloped labor supply curve. Right? Now let's talk about the decision to actually work. Just the decision to enter the labor force. Right? So we're not talking about hours worked, we're going from zero to positive. Right? So if you're not working, your hours worked is zero. You're deciding whether to work at all. Right? So this is like a binary decision. It's a 0-1 decision. 0, not working, 1, working. Right? So how do you think about this in terms of microeconomics, in terms of our consumer theory? Right? And so here we have to define something called the reservation wage. And the reservation wage is defined as the lowest wage rate that would make the person indifferent between working and not working. So at this stage, the person is on the fence. He's indifferent between working and not working. So what does this reservation wage equal to? It says here, the reservation wage equals the marginal rate of substitution of leisure for consumption, MRS sub LC. And what is this again? This, if you recall, as I mentioned a short while ago, is the slope of the indifference curve. So the reservation wage is the slope of the indifference curve at the point on the budget line corresponding to 0 hours of work. I'll explain this in a minute. Okay? Now, it says here, second paragraph. Recall that the marginal rate of substitution is the number of units of consumption that the worker must be compensated with if an hour of leisure were taken away from her. Right? This is what we mentioned in slide 16. Right? So hence, if a worker's reservation wage were $5, she would need to be compensated with 5 units of consumption, valued at $5, assuming the price of the consumer good is $1, right? If an hour of leisure were taken away from her. In other words, if this person's MRS is equal to 5 at the point of no work, this person would need a wage of at least $5 in order to give up an hour of leisure. This person would need to be compensated with $5 worth of consumption, which can only be financed by $5 of wages. You follow me? So this person would need to be given $5 in order to even work 1 hour. Right? Now let's say this person were offered a wage of $4. Would this person choose to work? Would a compensation of 4 units of consumption be sufficient to induce this individual to give up an hour of leisure? The answer is no. Why? because his marginal rate of substitution at the point of no work is $5. He would need a compensation of $5 to give up an hour of leisure. If you're offering him $4, he will not accept. Correct? So it says here, if the market wage is less than or equal to the reservation wage, then the person will not work, right? So what is the reservation wage? What's the point of no work again? Point of no work is point A. That's where you have the kink on the budget line, is that correct? The height here, this height, that's non-labour income. So if you were to draw an indifference curve through point A, right, and at point A itself you work out the slope of the indifference curve, the MRS, marginal rate of substitution. Well, that slope is in fact the reservation wage. In other words, if this individual were offered that wage, in other words, if the budget line were this line here, with this check mark here, of course extending all the way to the vertical axis, it's not fully drawn. But if that were the budget line, then this consumer's best point would be point A, the point of no work. Correct? Right? In order to induce him to work, a higher wage than this slope would need to be offered. A higher wage than this slope would need to be offered. Right? Now what happens to the reservation wage with a hike in non-labour income? The non-labour income would arise so that the new kink is at point B. Point B becomes the point of no work. Right? So what's going to be the slope of the indifference curve through point B? Is it going to be the same as the slope of the indifference curve at point A, or is it going to be steeper? Well, and here we need some microeconomics. Right? The fact is that as we move in a vertical direction, indifference curves become steeper. The MRS goes up. Remember, what is the MRS? The MRS at point A is what? It's the amount of consumption that the individual would have to be compensated by if a unit of leisure were taken away from him. Correct? So let's compare point A and point B. At point B, the individual has more consumption because the individual has more non-labour income. Now with more consumption, this person's marginal utility from consumption has fallen. This is the law of diminishing marginal utility. The more you consume of a good, the less you like it at the margin. You follow me? So at point B, because point B involves more consumption than point A, the individual likes consumption less at the margin. And so in order to compensate him for an hour's loss of leisure, in order to compensate him, you'd have to give him more consumption than at point A. Right? Because he likes consumption less. So you'd have to give him more of this good, this consumption that he likes less, in order to compensate him for the loss of an hour of leisure. Right? In other words, the MRS has gone up. The slope has increased in absolute value. Right? So at point B, the slope of the indifference curve is higher in absolute terms than at point A. Right? And what is that slope again? What's the slope of the indifference curve at the point of no work? Well, that's our reservation rate, isn't it? So the prediction here is that as non-labour income rises, we have a rise in the reservation wage. The very last sentence of this slide. The reservation wage increases in non-labour income. Right? So if you have a bunch of people who are not working and you want to induce them to work, right? Of these people, the person with the higher non-labour income will need more inducement. You'll have to offer him a higher wage to cause him to budge and enter the labour market, enter the labour force. Right? As compared to someone with less non-labour income. Right? So the people with higher non-labour income, they are more choosy. They're more difficult to induce to enter the labour force. So let's now look at what's happening here. So let's consider point E. Point E is the point of no work, as you can see here. That's where the budget line kinks. This is the original budget line. So this is the now that's the wage being, that's the wage, that slope. Let's call it W1. At that wage, is this person going to work? Well, no, because you see I've drawn this indifference curve through point E, the indifference curve labeled U0. So what's the reservation rate of this person? It's the slope of the indifference curve, the MRS at point E, and that's this more solid blue line. And you can see that this solid blue line is steeper than the budget line. So W1 is less than the reservation rate. Reservation rate is this slope. So you follow me? That's the reservation rate. This is supposed to be a horizontal line, by the way. It's not drawn particularly well, but you see what I mean. So this slope is the, I'll call it W sub R, reservation rate. So W1, you can see, is less than WR. Right? So the person is not going to work. Correct? So in order to induce him to work, a wage higher than WR would have to be offered, and that will be the slope of this line here. Right? When that happens, the individual's best point moves from point E to point Y. At point Y, what's happening? At point Y, the individual is consuming less leisure than capital T hours. In other words, hours of work goes to this. Used to be 0. This is hours of work. It goes from 0 to something positive. Right? So this is how you can think about the choice of working, the choice of entering the labour force. Right? In order to enter the labour force, an individual will have to be offered a wage that exceeds her reservation rate. Right? And her reservation rate is going to be higher the higher her non-labour income. Right? And we're going to talk about this shortly in perhaps part 2 of this lecture series, part 2 of the lecture on this chapter. And you will learn that the more generous are the government's welfare payments, the more difficult it is to induce people to enter the labour force. And can you understand this in terms of what we just learned? Because welfare payments are like non-labour income. The higher the non-labour income, the higher the reservation rate. So if a government gives out very generous unemployment benefits or welfare payments to people who are not working, well, it will be very difficult to induce them to, in fact, enter the labour force. You need to offer them a very high wage to cause them to enter the labour force. Right? So that's something that comes out of this microeconomics. Now we come to the labour supply curve. Right? And the first bullet item says that wages slightly above the reservation wage, the labour supply curve tends to be positively sloped because, as I mentioned, at lower wages, the substitution effect dominates the income effect, right? So at lower wages, what is true? And the substitution effect dominates, and you have a positively sloped labour supply curve, right? A hike in the wage induces the worker to work longer hours at wages slightly above the reservation wage. The income effect begins to dominate, second bullet item, the income effect begins to dominate the substitution effect as the wage rate increases beyond a very high level. So this brings us essentially to a labour supply curve that is like this. So along the horizontal axis we have hours of work, quantity of labour supplied in terms of hours. On the vertical axis we have the price of labour, the wage rate. And so what is the reservation wage in this story here? You can see here the reservation wage is $10 because at the wage of $10 the hours of work is 0. So you need to offer more than $10 to induce this person to work at all. Right? And so in the beginning, as wages rise from 10 to $13, this person starts to supply hours of work, 0 to 20. So you have a positively sloped labour supply curve up to a point. When the wage in this story rises above $20 an hour, once it goes above $20 an hour, it seems that the income effect starts to dominate and the individual's hours of work start to reduce. And so this is a backward bending labour supply curve. Right? So this has been observed empirically. Analysis of data has shown that at very high wages, not $20 I don't think, but at some very high wage, you might see this labour supply curve becoming, instead of positively sloped, becoming negatively sloped. The labour supply elasticity. Right, again, this is something that you would have learnt. Demand and supply elasticities you would have learnt in Econ 2302, principles of microeconomics. So what is the elasticity of supply about? The elasticity of supply essentially measures what? It measures the percentage change in quantity supplied from a 1% change in price of the item. So since we're looking at labor supply elasticities, we'd be interested in the percent change in hours worked following a 1% change in the wage. Right? And this is calculated as the percent change in hours worked divided by the percent change in the wage rate. Right? This is again standard from Econ 2302. That's how elasticities are actually calculated. Right? So let's say the wage changes by 10%. And this causes the hours worked to go up by 20%. Right? So again, 10% hike in wage causes a 20% hike in hours worked. What's the price elasticity of supply? Right? Remember, the price elasticity of supply would be the percent change in hours worked from a 1% change in the wage. In our case, the wage has gone up by 10%, not 1%. Right? So how do we figure out the effect of a 1% hike in the wage? Well, we divide the 20% change in hours worked by 10. We're prorating here. Right? You understand what I said? Let me just write it down again. So let's say that a 10% rise in W causes a 20% rise in H, hours worked. We need to figure out the elasticity of labor supply. So what we want to do here is conduct this thought experiment. That is, we'd like to convert this 10 into a 1. We'd like a 1% hike in the wage, a theoretical 1%, a hypothetical 1%, and see what this 20% becomes proportionately. Now, if this 10 were to become 1, this 20 would become what? Wouldn't that become 2? That's 20 divided by 10, in other words. Right? We're prorating. Right? So that's how we arrive at that 2. It's 20% divided by 10. So we take the percent change in hours worked and we divide it by the percent change in the wage rate. And that number there, which is just a number, it doesn't have a percent sign next to it. Right? And that number is the elasticity of labor supply. So it says here, a labor supply elasticity of 1.2 would imply that a 1% rise in the wage induces a 1.2% rise in hours worked. Now what if the elasticity of labor supply is sigma here? Let's say that it is positive, meaning, of course, if that's positive, that must mean that which effect dominates, the income effect or the substitution effect? Of course, if that's positive, that must mean that when wages rise, hours worked rise. Right? So the substitution effect must be dominant. Right? So that's true, and let's say this, and then this is also true. So sigma, the value of the elasticity of labor supply, lies between 0 and 1. In that case, we would say that the supply of labor is inelastic. Why? Because a 1% hike in the wage induces a less than 1% hike in hours worked. So the workers' hours worked is not very sensitive to changes in the price. The workers' hours worked or labor supply is inelastic. On the other hand, if sigma is bigger than 1, then we say that labor supply is elastic. Because this would mean that a number like, say, 2, a sigma were equal to 2, this would mean that a 1% hike in the wage induces a 2%, bigger than 1% hike in hours worked. So that's a sensitive, elastic labor supply. The workers' labor supply response is sensitive, highly sensitive to a change in the wage. How do we estimate labor supply elasticities? And this is done usually by the means of regression equations. Again, I'm not going to get into regression equations because it's something that you will learn in econometrics. Perhaps some of you are taking econometrics this semester, or have taken it in the past. So I'm not going to get into the details here, but essentially we estimate an equation like this using data. Right? So we would have individual data. Right? So essentially we would have the following situation. We would have hours worked and wages, and each observation would be a dot in this space. So these are individuals. Workers will have their wage, hours work combinations. And what regression analysis does is it attempts to pass a line through the scatter of points in a way that describes the average relationship between the two variables. Right? So in order to figure out the labor elasticity, we estimate an equation like this. So we would expect this number to be positive as long as the substitution effect dominates the income effect, correct? Right? So we would expect this to be positive generally for most people, right? And this we would expect to be negative because this would be a pure income effect. The higher the V, the non-labor income, the higher the non-labor income, the lower the hours worked. And I've demonstrated this, correct? If you have this parallel rightward shift of the budget line, hours of leisure consumed increases. In other words, hours worked falls, unambiguously falls, unless leisure is an inferior good, which it generally isn't, right? Which is unlikely. Right, so this is the kind of regression equation that's estimated. And there are two problems with this regression, as the book mentions, and one of the problems involves salaried workers. So these are salaried workers and workers who don't work set hours. They receive a set salary, right? They receive X dollars a month, but their hours worked vary. On days where there's a lot of work in the office, the guy stays a little late in the office, otherwise he leaves early, etc. Right? So how do you take a salary and convert that into an hourly rate? Because remember, in this equation, W is an hourly wage. So how do we convert a salary into an hourly wage? We basically take salary and we divide it by hours worked. So we have to ask the individual, how many hours did you work last month? If the salary is a monthly salary. Or how many hours did you work last week if the salary is a weekly salary? Right? Now this of course involves some problem because the individual will have to go and think back to last week or last month and say, how many hours did I work? And he's going to blurt out an answer which may be a little wrong. There may be error. He may have forgotten. You see? So if you measure wage in that way, this W now begins to have measurement error. Right, so let me just write that down. So this variable V begins to be plagued by measurement error in the case of salaried workers. Now this is something that you may have learned in econometrics. If you haven't learned it, don't worry about it. I'm just going to give you a fact, and that is that when you have measurement error in one of the regressors, the estimated coefficient of that regressor tends to be biased towards 0. Remember, we expect this B to be positive, right? But our estimated B would tend to be smaller than true B if W is measured with error. Correct? So this would tend, now remember, what causes B to reduce in size? The income effect. The substitution effect pushes B upwards. Right? Because what is B again? What is B showing us? B tells us the amount by which hours of work would rise if the wage went up by $1. That's what B is, the slope, right? Now let's say that B is equal to 3. That would indicate that for every $1 hike in the hourly wage, this worker increases hours worked by 3 hours. And this is because the substitution effect dominates. Now this 3 would fall to 2 if the income effect started to become stronger. Because the income effect, remember, causes the individual to consume more leisure. Right? Now when we estimate this regression, we end up underestimating the B. What that tends to do is it makes us overestimate the strength of the income effect. In other words, by running this regression, we are basically arriving at this falsity that the income effect is stronger than what really is. Why is that? Because we are underestimating the B. Our estimated B is lower than true B. And that is because W is being measured with error in the case of salaried workers. So that's a problem with this regression. The other problem with this regression involves non-labor income, C. Remember, we expect C to be a negative number, right? Because the higher the non-labor income, the greater the amount of leisure consumed, as we've studied. But the problem here arises this. V is generally a return to past saving or investments. People derive a lot of non-labor income from, let's say, dividends from stocks owned, company shares. Right? So a person who has a lot of company shares will get a lot of dividend income. And this would be non-labor income. Right? But to have a large stock portfolio, this person would have had to perhaps work very hard early on in life. Right? Work long hours, make a lot of money, save a lot, invest those savings in stocks, and then now enjoy the high non-labor income. So people with high non-labor income are people who work very hard in the past. Right? They may have been hard workers in the past. It says here that if these habits of hard work persist to the present, this is a person with habits of hard work. He's a hard worker by nature. So even now, when he has a lot of non-labor income, he may continue to work hard. He doesn't know how to relax, when you think about it. Right? This is a person who's diligent, who works hard, saves money, increases his wealth. Right? These are the habits he has. This is his nature. So even later in life, when he has a lot of dividend income, a lot of non-labor income, he continues to work hard. So what that ends up doing is it causes this C, when you estimate this, it causes us to estimate the C as perhaps being even positive, where in theory tells us it should be negative. Right? So there will be upward bias on the C. In other words, we won't be estimating a true C. Right? Because the true C is supposed to be negative by our theory. But we may end up with a positive C. In other words, people with high non-labor income also work longer hours. And that's simply because of this persistence, because they are by nature hardworking, or they tend to be like that. That is how they accumulated this wealth. It generates high non-labor income. Right? So these are two problems with this regression. Then I don't have the time to teach you regression, so this course, this labor economics course, is ideally taken by a student who has background in economics. Okay? It's not required, but it's preferred. The labor supply of women. And here the facts are there are substantial cross-country differences in women's labor force participation rates. So there are many countries out there where a very small fraction of women participate in labor force. In my own country, the country of my birth, I am a naturalized American, but India, where I came from, has a very low female labor force participation rate, something like 21%. So only 21% of women in the working age population are actually in the labor force. Right? And that figure tends to be much, much higher. I don't have the exact figure for the US, but I suspect it's greater than 50%. Right? The second point about female labor supply is that over time, women's labor force participation rates have increased. I mentioned this before in an earlier slide, right, where I also noted that male labor force participation rate has decreased long term. Right? In most studies of female labor supply, the substitution effect generally dominates the income effect. So women tend to have positively sloped labor supply curves. Right? Their backward bending portion doesn't tend to show up. Understanding women's labor supply using a model of household production. So here we have a husband and wife, and here we have their production possibility frontiers. Remember this term from principles of macro and principles of micro, correct? So this is the husband's PPF. What does this indicate? This says that if this person, this husband, devoted all his time to household work, producing household goods, what would household goods be? That would be like cleaning the house, cooking, things like that, right? Right? So if all that time, all this husband's time is devoted to household production, 100 units of household goods would be produced by this person. That's dictated by his capabilities. On the other hand, if this person devoted all his time to work in the market, in the labor market, this person would be able to earn $400, enabling him to buy 400 units of market goods. This would be the consumption goods that people buy in a store, right? So this describes the husband's PPF, and this is the wife's PPF, right? So if the wife devoted all her time to household production, she could produce 400 units of household goods. On the other hand, if all her time was devoted to the labor market, she'd be able to earn $100. Now, this is, of course, not, this is just an example, right? So what we're trying to show here is that the husband has an absolute advantage in market work. He's better than his wife in market work. The wife is better than the husband in household production. This is a very traditional setup. This is the way things were perhaps in your grandparents' day. And this is clearly no longer true, right? Let's just go back to those years and see what we can do here. Right? We can combine the two PPFs to arrive at a household PPF. Right? So this here is the household PPF. So what is this 500? This 500 that you see here, well, this would be if both wife and husband devoted all their time to household production. Right? But remember, if the wife devotes all her time to household production, she can make 400 units of the good, right? And the husband can make how much? 100 units of household goods. Add them together, you arrive at the 500. Right? At the other end, we have this other 500, and this is 500 units of market goods, 400 contributed by the husband, working in the market all the time, and 100 contributed by the wife, who also then devotes all her time to producing market goods or working in the labor market. Right? So this adding these two gives us a sort of kinked PPF, as you can see. Right? And now we have a bunch of indifference curves here, depending on what preferences are like, but it could be that the best point is point B. Now what's true at point B? Point B, 400 units of the household goods are consumed and 400 units of the market good are consumed. This is only possible if the wife devotes all her time to household production and the husband all his time to market work. So the best point may be that kink. So at that kink then, the wife is a housewife completely and the husband goes out and works. That could be the best point, right? On the other hand, if you have a steeper indifference curve, now what would a steeper indifference curve indicate? Remember in the consumption leisure space, steeper indifference curve bespeaks a person who values leisure more, right? Because you'd have to compensate him with more consumption when you take away an hour of leisure from him, right? Remember that? In this space we have household goods on the x-axis. So a steeper indifference curve would indicate that this person would need to be compensated by a lot of market goods if a unit of household goods were taken away from him or her. Of course, here we're talking about the couple. Right? So steep indifference curve indicate that household goods are highly valued. Right? So in household, highly valued household goods, the best point may be point A. Now at point A, the consumption of household goods exceeds 400. And this is only possible if the wife devotes all her time to household production and the husband too pitches in some of his time into household production. So the husband is actually taking some time off work to contribute to household production. Right? So that's point A. So this is a household that really values household goods. Now this might be, child care is a household good. So this might be a household with many small children, right? Where the husband too has to pitch in to help out because the small child needs intensive care, etc. That could be this household, a household with young children, right? On the other hand, consider a flatter indifference curve. If you have a flatter indifference curve, this is a household that doesn't value household production very much, doesn't value household goods very much. So this could be a household without small children. The children have grown up, gone to college, gone away to college. So now the best point may be point C. At point C, you notice that the household is consuming more than 400 units of the market good. Now this is only possible if, besides the husband working all the time in the market, the wife too begins to contribute part of her time to working in the labor market. That's the only way the household can afford to buy more than 400 units of the market good. Correct? So at point C, husband works all the time in the market, in the labor market. The wife spends part of her time in the labor market and part of her time in household production. Right? You will notice that at point C, the wife is working in the market and working at home. The husband makes no contributions to household production. Right? So in this setup, what would cause a household, what would cause a wife to start to enter the labor market? So let's say the best point is point B. Right? So let's say that, or point A, okay, in this diagram. So let's say the best point is point A. This is the indifference curve in the collective label U0, right? And best point is point A right here, as you can see. Right? So in this setup, the wife is specialized in household production and the husband is specialized in working in the labor market. Correct? How to induce the wife to start to work? The one thing that would induce her to do so is if her productivity in market work went up. In other words, if she were offered a higher wage, right, then the curve would become like this. So what is essentially happening is, coming back to this diagram, the wife's PPF is becoming steeper like that. You follow me? The wife's PPF becomes steeper like that. In other words, if she becomes more productive in market work, if she's capable of earning more per hour in the market, if that happens, but this can happen not because of any change in her skill set. This could be a result of legislation, anti-discriminatory legislation, right? Legislation that bans, that outlaws gender discrimination in the labour market, for instance, right? And that causes female wages to go up. Right? And if that happened, then you would see this change in the shape of this household PPF, right? And now you find that the best point becomes point B, right? And, but what's true about point B? Again, you can see that would be kind of like point C in this diagram, right? And what does point C denote? This means that the husband is specialized in market work and the wife is devoting at least some of her time to market work as well, right? So that would cause an increase in women's participation in the labour market. So if you think about the sharp increases in female labour force participation since 1900, figures that I showed you a short while ago, well, one reason for this might be this change in women's labour market productivity. Right? And this could be a result of an increase in women's skills. Women are getting more education now than they used to. Right? So they're capable of earning more in the labour market. Right? That's one, correct? Another reason might be that well, besides this, you could have a change in preferences as well. Right? And let me explain this. Households these days are having fewer children. Now remember, I said that a household with young children would have steeper curves where the optimum might be at point A or point B. With a flatter curve, the optimum moves to point C. Now with households having fewer children now than in the past, the indifference curves are becoming flatter. And so that, again, by itself, without any change in female wages, that by itself would tend to cause a movement, a migration from an optimal at point B to an optimal at point C. Women would start to work. Right? So these are the kinds of factors involved, I think, in this big hike in female labour force participation. Right? And that's the end of part 1 of my lecture. Part 2 will look at certain policy applications.